that's got open and closed loop. In words, the concept of, and that's the video that C's going to put up there from that lecture. One of the concepts is that if it's a closed loop process, you're measuring a process output and you're using that information to adjust some input. And that's the key thing that you're looking for, is some output. You're going to measure temperature, pressure, concentration, light levels, whatever sensor thing you want to use. You're going to use that to adjust some input. Again, that can be flow rate, pressure, energy input, electrical input. One of the key things on open loop is on any timed process is going to be an open loop. So you've gone to an intersection and the lights, the traffic lights are just on a timer. That's an open loop process. It doesn't matter how backed up people get one way or the other. It just goes by that time. But if you've got a smart intersection that has sensors in the road, that would be considered a closed loop, because you're detecting traffic, making adjustments to the lights. If all you're doing is you're looking at a process that's going to do something and then it's going to just print out or display the output, that again is an open loop, because the reading that you have isn't adjusting any of the inputs. So that's an open loop. Some more closed loop examples. Cruise control in an automobile is a complex one. You set that cruise control. If the hill, if you go up a hill, your automobile will increase its speed. If you start going down here, it'll start slowing you down, things like that. So it's making that adjustment. If you're adjusting air pressure or flows, things like that. So one student last year looked at chlorine levels in the swimming pool, measured the concentrations, and then made adjustments in how much chlorine got added to that to keep the concentrations with that. Any kind of mixing problem where you're trying to keep a concentration, aeration of a tank where you're trying to keep the oxygen level either for fish or aerobic treatment or something. Again, you measure the oxygen level, you adjust the flow rate and things like that. So those are examples of it. Had a student last year that was into cross-country skiing. It wasn't cross-country, but anyway, skiing, and was measuring the flexibility of the skis that they would rent to customers, and they'd write a recording on that. So he came up with a design for how to measure that and then printed it out. That actually was an open loop because again, just printing out the results wasn't a thing, but it was such a fascinating topic. Go by with it. So that's some examples. If you got questions, again, I'll be here for a little bit. Send me an email, and what we'll do is we'll read yours. What we're interested in, again, is your description of what your process output is and what you're measuring, and then what kind of an actuator you're going to be, or what you're going to control with the input. Those are the two key kinds of things we're looking for in that. Any questions?
This first assignment to catch us if we're making a mistake and it's not closed loop, or would you like us to email you if we have any doubts in our mind?
My suggestion is if you have doubts in your mind, send me an email. But your answer to the first question you had is yes, this is to catch those, and then we say, well, okay, so now how can we change this into a closed loop or something like that? But the sooner you catch it, the less time you spend going down a path that's not going to work, and you have to redo that. Okay? Thank you.